Stainless steel is an alloy that is a mixture and not a chemical compound of iron, chromium and nickel. A piece of stainless steel consists of 70% iron, 20% chromium and 10% nickel by volume. The relative densities of iron, chromium and nickel are 7.8, 7.2 and 8.9 respectively. Find the relative density of stainless steel. Okay, let's suppose that we have our block of steel. Of course, the metals that make it up are mixed in through it, but we can just represent it like this. Let's suppose our block of steel has volume V, then iron is 70% by volume, so the volume of iron in this block will be 0.7 V. The volume of chromium will be 20% of V or 0.2 V, and the volume of nickel will be 10% of V or 0.1 V. Now, to get the relative density, we will have to consider the mass of this volume. So this is the mass of the steel. That's obviously equal to the sum of the masses of the constituent metals. How do we get the mass of the iron? Well, we take the volume of the iron, 0.7 V, and multiply by the density of iron. The relative density of iron is 7.8, so its density is 7.8 times 1,000, 7,800. I've just done the same for the chromium, and for the nickel the volume is 0.1 V, the density is 8,900. Now to get the mass of the steel, we get the volume of the steel, which is V, and multiply it by the density, which is rho. Okay, we don't know what the density of the steel is, but now you can see that we can find it because we divide everything by V. So now we have the density of the steel. It's 7,790 kilograms. Now we want the relative density, so we have to take the density of the steel and divide by the density of water. The units cancel out and we get 7.79. So the density of the steel is 7.79 times the density of water. V1 centimeters cubed of liquid A of relative density 0.8 is mixed with V2 centimeters cubed of liquid B of relative density 0.9 to form a mixture of relative density 0.88. The mass of the mixture is 0.44 kilograms. We want to get the values of V1 and V2. Let's get the density of liquid A. Its relative density is 0.8. So its density is 0.8 times 1,000, which is 800 kilograms per cubic meter. The relative density of liquid B is 0.9, so we multiply that by 1,000 to get 900 kilograms per cubic meter. So the relative density of a substance is the density relative to water. So liquid A has a relative density of 0.8, means that its density is 0.8 the density of water, 0.8 of 1,000, which is 800. Now we want the mass of the mixture, so we want the mass of A added onto the mass of B. So how do we get the mass of A? Well, the mass of A is the density of A times the volume of A. Density times volume is mass, and the mass of B is the density of B times the volume of B. So we are assuming that we are dealing with liquids that have uniform or constant density. Okay. The density of A is 800, and the volume of A, well, actually the volume of A is written V1 here. VA is V1 and VB is V2. Okay, I'll just use letters A and B, it's just a bit easier to read, I think. The density of B is 900. So this is the total mass of the mixture, and we are told that that is 0.44 kilograms. Now we are given the relative density of the mixture. How do we find the density of the mixture? Well, we take the total mass of the mixture, which is 0.44, and divide by the volume. Mass over volume gives us density. So what's the volume? Well, that's the sum of the volumes of the constituent liquids. This is the density. Okay, the relative density is 0.88, so the density is 0.88 times 1,000. That's 880 kilograms per meter cubed. So you can see now that we have two equations and two unknowns. That means we can find those two unknowns. Two linear equations in the two unknowns VA and VB. Okay, I won't bother solving between these two equations, that's straightforward. We find that VA is 0.0001 meters cubed and VB is 0.0004 meters cubed.